Have you ever heard of the Mars Climate Orbiter? Probably not, because it was lost during a mission to Mars, but that's what makes its story so important. You see, this is the story of how we learn from our failures and turn them into future successes. The year is 1998. NASA has launched their Mars Climate Orbiter, an advanced spacecraft designed to study the atmosphere of Mars. Now, you might be asking yourself, why do we need to study the atmosphere of Mars? Well, Mars could have once been habitable. So if we want to search for life there today, or send people there in the future, we need to know all about it. This mission was very important, but as with all things that are very important, they were also very complicated. And like all complex missions, it had many different parts. This orbiter had several instruments on board, including two cameras, a spectrometer, and a thermal mapper. All of these instruments had one job: measure and collect data about the atmosphere. Now, this particular orbiter had a little extra challenge. Not only did it need to gather data about the atmosphere, but it also had to do it while taking really cool pictures of the planet. In order to pull that off, this orbiter had a special camera called the Mars Global Surveyor Camera, or the MGSC. The MGSC was a fancy camera made up of 7 different lenses. It took pictures at a resolution of 17 meters per pixel. That's pretty high resolution, especially considering it was orbiting a planet over 200 million kilometers away. The mission began, as all space missions do, with a launch. On December 11, 1998, the Mars Climate Orbiter lifted off from Cape Canaveral aboard a Boeing Delta II rocket. Now, this isn't the first time I've covered this mission. If you go back and watch my video about the Mars Polar Lander, you'll see that it also launched on this same rocket. Yes, both the Mars Polar Lander and the Mars Climate Orbiter launched on the same rocket. I just love the fact that space stuff is so interconnected. Anyway, after successfully launching from Earth, the next step was to get to Mars. But in order to get to Mars, you need to get out of Earth's orbit and head into deep space. To do that, you use something called a transmars injection burn. Basically, your engines fire for a short time to put your spacecraft into a new path that takes it farther away from Earth and eventually towards Mars. This is where things went wrong. On December, engineers on the ground commanded the Climate Orbiter's engines to fire for the transmars injection burn. Everything seemed to be going well until engineers started looking at the telemetry data coming back from the spacecraft. Something wasn't right. The burn should have lasted 12 minutes, but according to the data, it lasted 6 minutes. This was a big problem because if they didn't correct course now, then the Climate Orbiter would never reach Mars. So on January, another burn was performed to correct the trajectory. But unfortunately, this burn didn't last long either. After just 4 minutes, the burn was cut short due to a valve sticking in the fuel system. At this point, NASA knew that the Climate Orbiter would never make it to Mars, but before everyone got too upset, let's take a moment to appreciate the fact that even though this mission was lost, NASA still managed to get incredible science from it. During its brief time in space, the Climate Orbiter took some of the most amazing pictures we've ever seen of Earth from space. But even though this mission was lost, NASA didn't give up. They had 2 more attempts to land on Mars, the Mars Polar Lander and the Spirit rover. And if you want to hear about those missions, then stay tuned for more information. After the loss of the Climate Orbiter, NASA needed to figure out what went wrong. There were a lot of people involved in this mission and thousands of parts. So how do you go about finding the source of the problem? Well, you take a step back and look at the big picture. When you break it down, you can see that there were really 3 main components to this spacecraft: the bus, the propulsion system, and the scientific instruments. Each of these systems were built by a different team of people. The bus was built by Lockheed Martin, the propulsion system was built by Aerojet, and the instruments were built by various universities and companies across the United States. Now, obviously, none of these teams set out to build a faulty spacecraft. So in order to find the source of the problem, NASA needed to know which team was responsible for which part of the spacecraft. They also needed to know who built which piece of equipment and who operated which system. To make matters worse, these people weren't the ones who worked on the Climate Orbiter. Today, NASA has standardized all of their work orders and processes. But back in the late 90s, that wasn't the case. Every team used different forms and different ways of tracking their work orders. This meant that no one had a clear idea of who was responsible for building or operating what. NASA realized that they couldn't fix the problems if they didn't know who was responsible, so they decided to implement a system called Configuration Item Responsibility Tracking System, or CIRTS. With CIRTS, everyone working on a project would submit a document that detailed every single thing they worked on. Then, when there was a failure, NASA could easily track down exactly where the problem occurred. With this new system in place, NASA was able to determine the cause of the failure. The valve that broke on the way to Mars wasn't actually faulty, it just hadn't been installed correctly. The team who built the valve had accidentally tightened it too much, which caused it to fail when it got to space. This was a huge deal because it wasn't just one person who was responsible for this valve. It was the result of multiple people making small decisions throughout the entire process. Sometimes these decisions were made by people who no longer worked for NASA. Sometimes they were made by contractors who were hired for a specific task. And sometimes they were even made by other space agencies. In the case of the Climate Orbiter, the valve itself was built by a company called Parker-Hannifin. But the real problem lay in how it was tracked and documented as it moved through the system. The ultimate responsibility for this valve lay with NASA, and they needed to make sure that it never happened again. So they developed a new plan to make sure that if anything like this happened again, they would be prepared. First, they needed to change their entire engineering culture. Back in the late 90s, engineering was a profession dominated by men. And like all male-dominated professions, egos played a big role. People wanted to look competent, so they often shied away from asking questions. But NASA knew that asking questions was crucial to solving this problem. So they made it a priority to hire more women into engineering. Women tend to ask more questions, so this helped improve the overall quality of their engineering. Second, NASA created a new system called Design for Failure. This meant that whenever they were designing a new spacecraft, they would intentionally try to break it. By intentionally trying to break their machines, engineers were more likely to identify potential failure points. They would also be more likely to report small problems before they became big problems. Finally, NASA created a new organization called the Failure Analysis Board. This board would be responsible for investigating any failure that occurred during a mission. They would also be responsible for coming up with ways to prevent those failures from happening again. These changes were so effective that they're still being used today. The Failure Analysis Board is still around, and many of their recommendations are still being followed. These changes even led to a major shift in how NASA does business. Today, NASA encourages employees at all levels to come forward with questions and concerns. They've even created a special hotline where employees can report problems without giving their name. All of these changes have led to a safer, more efficient NASA, and it all started with one simple valve. The Mars Climate Orbiter may have been lost, but its legacy lives on in the form of better spacecrafts. If you want to learn more about this story, check out the description below. Thanks for watching, and I'll see you next time.